All right. Hello, guys. Welcome to another one of our React sessions. And today we're going to be talking about how to use the useReducer hook to manage state for nested objects. And we're going to talk about the different types of objects that are in JavaScript, different data types, and how sometimes useState isn't always the best option for us. So first, let's take a look at the useState hook that we've used before. And as you can see here, with useState, we can do something simple where we have a variable to grab our state variable, and we have a setter to set our state, like so. And today we're going to talk about something like useReducer and how that's different from useState. So first, let's talk about how React state management works and how exactly do we know when to re-render something? How do we know, oh, I want to change how this looks on the website? And the way that we do that is what React does is that it compares our previous state objects. And if it's different through something called the object.is comparison, then it'll fire a re-render and show different things on the page. Now, let's talk a bit about what object.is comparison is. And there's a couple things that work with it, like primitive types versus references for object.is. So we're going to take a little bit to go through each one of them. And first is primitive types. Let's see this example here. Let me pull up Node real quick so we can see. Let's see. So can you see my terminal? Maybe let me try sharing just the terminal so it's a bit bigger. There we go. Is that better?
Yeah, it's bigger.
Nice, nice. All right. So let's take a look at something we want to do. Let's say we have a number, the 56, and then we want to make a new variable, call it numRef equals number, like so. And if we print out what number is, we get 56. If we get numRef, we get 56. And if we change what value number is, like so, and we see what value number is versus numRef, we can see that they are two different numbers. And if you do object.is number numRef is us false. And we can see that how come even though we called numRef to be equal to number's value, when we change numRef didn't change as well. And that is through something that, give me a sec to start screen sharing my desktop again. There we go. And that is because numbers is something called a primitive type in JavaScript. And example of the 5 primitive types are booleans, null, undefined, string, and number. And to get a better understanding of what exactly primitive types are, let's see how the values are stored in memory. And we can see this little table that we have set up here, where we have the mynum variable, which is 56, and numRef, which is also set to 56. When we set, excuse me, when we set numRef equal to mynum, we get the value that mynum points to and puts that inside of numRef. And when we change mynum's value to 50, we see that numRef's value stays 56. And this is something that we're used to seeing in a lot, like in C++, in other languages with primitive types. And now let's see references and how that might be different. Oh yeah, real quick. So the object.is comparison, what it does is that it looks at the value that is associated with the variable and compares them. As we can see here, 56 is not equal to 50, which is why object.is gave us false. And now let's take a look at references and seeing how they're different. Say for instance, I want to have an array called r equals 1, 2, 3. And then we have let ref equal 1 equal r. We want to console.log what r is. Oh, I'm sharing the wrong thing again. Give me a sec. Sorry about that. There we go. We want to see what r is. So 1, 2, 3. ref, which is also 1, 2, 3. Now, let's say we want to change the value of r. Like let's say r index 2 equals 10. When we print out r, we see that it's also 1 to 10. And we print out ref, it's also 1 to 10. Now they look really similar, right? What if we run object.is comparison on them? Object.is ref, which contains the values that they point to. And you can see that in JavaScript's eyes, they are the same object. Now, why is that? Why is references different than primitive types? And as we can see, let's take a look at how references are stored inside memory. Like we see the variable r and the variable ref. Because the array that we're passing in is not one of the 5 primitive types, instead we pass in a reference to a value, which is kind of like a pointer in other languages like C++ that we've used before. So let's see what the value is associated with r. We can see that we have a memory address, which is like, say, 001, which contains our objects of arrays, 1, 2, 3 here. And say, for instance, when we set ref equal to r, like so, we see that we get, it's the same thing with primitive types, where we get the value that's associated with a variable and give it as well to ref. And we can see that whenever we change, let's say we change r index 2, we change index 2 of this memory address here. And we can see that's why 123 becomes 124 for both of them. Now, that is equality with assigning by reference versus assigning by value. And now let's take a look at how we can use the spread operator to make sure that different data types that we want are completely separate from each other. And what the spread operator is that it is these 3 little dots right here. And what the spread operator does is that it creates deeper copies of objects as opposed to shallow copies. And what we mean by deep versus shallow copies is that shallow copies are connected to the data by the same reference as we can see here, but deep copies are not connected at all and make a completely new address in memory, or they form a new object. So let's see what happens if we try changing this as so. Now let's change ref to be ... r, which is using our spread operator. If you can see, rf's value is 1 to 10. And let me start screen sharing Node again. Now let's say that we want to change r's value, r index 2, back from 10 to 3. If we take a look at what r gives us, we give 1, 2, 3. But when we get ref, we see that it's 1 to 10. And they are properly separated from each other. And if we want to take a closer look at this, let's look at how they're stored in memory again. Yeah, so if you look inside memory, we can see that when we use the spread operator, what it does is that it takes all of the values of the array and it puts all of these values 1, 2, 3, and generates a new array based off of these values, like so. So we can see that unlike in the previous example, where they point to the same address or reference in memory, we see that in our case, when we use a spread operator, we create a completely new object that is not tied to the previous one, like so. And there's one thing that is important to note about the spread operator, and that is that while we say that it's a deep copy, that's not 100% correct. In fact, it's one step deeper than a shallow copy. And what that means is that, like we said, it copies over the values from the older array. Like if we take the array of 1, 2, 3, we copy the value 1 over here, copy the value 2, and the value 3. But say, for instance, we have an array of arrays, like so. If in this example, we have, all right, let me set up a new example real quick. So let me start sharing Node. All right, so let's take a look at a couple more arrays. Let me start a new Node session so that we can get everything all set up. Like, let's say we want to have array of numbers be 1, 2, 3. Let's have another array be 4, 5, 6. And finally, another array be 7, 8, 9. And what we do is that we want to make an array of these arrays. We call it like something like num array equals R1, R2, and R3. Now, let's try doing the spread operator, like we said before, to get a reference to it. And let's call it like shallow copy. And this is how you use a spread operator. We put an array opening, dot, 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 and num array. So we take a look at what num array contains. It contains our 3 arrays, 1 to 9. And if you take a look at what shallow copy is, it's also the same. Now, if we try changing array index, let's try changing the value of 1. Let's make that like 100, for instance, of R1 index 0. Let's change that, or 10. Let's change that to 10. And when we see what num array looks like, it is 10, 2, 3. But even with our spread operator, what we see is that it's still a shallow copy. Like if we try looking at shallow copy, array 1 index 0 has also been changed. And the reason why this is the case, like if we take a look back in memory one more time, is that it's because when we use the spread operator, we take all of the values of the object and put them into our array. And the problem is if each value inside of the array is also another reference, then we're still making we're still making shallow copies. We're not truly making a totally original copy of the data. And let's see how we can make a deeper copy. And we can do this through functional programming with like, say, a mapping function. Like if I share node one more time. There we go. Nice. Like, let's say we want to make a true different copy of that array. We can do that as so. New array. And then what we do is that we're going to make a mapping function of our previous array. And what this is that we take each subarray, like call it sub R, and we're going to make a deep copy of each subarray, like so. If we see what new R gives us, and if we change array index 1 back to 1, let me take a look at num R, which gives us 1, 2, 3, 4, 5, 6, 7, 8, 9. New R has completely been separated away, and we've created a deep copy of it because we made sure, because we knew that each element is an array itself, so we have to make deep copies of the array. Do you have any questions on shallow versus deep copy, or like the one more step shallow, one step deep with the spread operator?
Oh, yeah, I'm not sure if I'm misinterpreting about like on that table where it has the value and like the address. But if you did object that is of array and then its spread operator array, would it still return true?
Let's try. Let's see what would happen. So we see that like ref versus R, we see that this is address 1, and like what this says in the table that is address 2. And let's see if that is the case. Let's try making a new node session so that don't clutter everything. Like, let's say R 1, 2, 3, and you say that if you make another thing like new R like this.
Yeah, with the spread operator, yeah.
Yeah. If we try using the spread operator, and using object.is, we see that in fact they are completely different arrays. And that's because with object.is, we compared the value that is associated with each variable. And because the value in this case is a reference to another array, and they're completely different arrays because it's one more step deeper, right? Creating a new array, a new address of memory.
Okay, thank you.
Yeah, nice. All right, so let's go back. Yeah, and now that was a lot about like references, primitive types, and how does it have to do with React? And what we can see is that in the past, we used things like useState for primitive data types, like the 5 we talked about before, Booleans, numbers, null, undefined, symbols. But if let's say that when we're making harder React or more expansive React application in the future, not everything can be stored as primitive data types. Like say, for instance, we had a complex object that we wanted to store in state, like a user object. And this is just some TypeScript things that we do with the user object. Like we have a name, likes, might have a status as well. And what we can see is that if we want to use state for this, we would have useState, give it a default state like so, user, and set user. Now, what if we wanted to modify like just the name, just the likes, or just the status of our user object? And what we can see is that the way we'd have to do this is with something called a SetState callback function and the spread operator. Now, if you take a look at the SetState function that we have here, what we see is that we're not passing a value directly like so. Like in the past, we just said, oh, we're going to set the state to this value. But if the state that you want to set to depends on the previous state, you can pass in an arrow function that'll take the previous iteration of the state and you can change it like so. Do you have any questions on what the spread operator syntax does or how this works? Nice. Yeah. So what this does is that we take everything that's inside of the previous user object and simply we just change the name portion, but keep everything else the same. And we can do that like so as well with increment likes with, oh, I'm going to make the likes go up by 1 for the user. And the problem with this kind of style for useState is that we can have all of our different state update functions like throughout different parts of the app. Like as we see here inside of a track user, it can get really messy if we have a lot of code splattered throughout everywhere. Like let's say we have a giant project, right? And there's more things in between each function. It's hard to keep track of what exactly changes the state, what functions we have is tied to the state, and so on. Sometimes it's really nice to be able to have a centralized place to put all of our state logic. And that's something that the useReducer hook can give us. Now, the useReducer hook. So what the useReducer hook is that it's similar to using Redux, which is a state management tool that helps to handle nested state. Like what we said before, if it's not a primitive type, then it is referential and nested object. And the useReducer hook is actually what is recommended by React itself for when we have complex state management, when we have state that depends on the previous state. And it also makes testing a lot easier because useReducer is somewhat of a pure function, which we'll discuss later. Now, how does useReducer work? In order to see what useReducer does, we're going to try taking a look at an example of a function of a little game, not a little game, but like a little histogram, like so. And we're going to want to do a lot of things with it. What we want to do is that we want to have this little histogram of data. And what we can do is that we can add specific fields. We can pick a number randomly. We can randomly pick 1. We can add 1 to everything, and so on. We can randomly pick a number. We can choose which one we want to pick, like so. And we're going to try seeing how we can use useReducer for this. And yeah, let's try going into this and seeing how we would use a reducer. So the way that useReducers work is that they're slightly different than previous functions that we used, like useState, because when we used useState in the past, like let's take a look back at useState, we see that all of the setup we have to do for useState is within the function itself. But for reducers, we have a little bit of setup both outside the function and inside the function if we want to use it. So let's take a look. What reducers do is that we have to set up an initial state and a reducer function outside of our component. So let's say let's take a look back at our reducer and see what we want the default to be. So by our default, we have like object 1, which has a value of 20 and decreases by 5 every single time. And let's see how we could set this up. All right. So here is like a little bit of TypeScript at the top, so we can get all of our types out of the way. And we can see that each section of the histogram has an X component, which is going to be the name of the section. Here, I can pull this up so we can see it as well. So each section of the histogram has an X component, which is going to be the string. It's going to have a Y component, which is the number associated with it, the count, like this, and a weight to it. And what the weight is that when we randomly pick a number, it ensures that everything gets a 20% chance each time. And the way that we're going to represent a histogram is an array of these sections. Like we're going to have this little object here is going to be one section of the array, and so on. And these are enums and interfaces, and we'll go into what these do in a bit. But first, let's talk about how we would use our set up our function with our initial state. And something we can do here is with something fancy with like a mapping function. Like if we have numbers 1 to 5, what we can do is that we say, oh, object 1, I'm going to give it 20. I'll give object 2 15, object 3 10, object 4 5, and object 5 0. And what this is that it sets up our histogram object. Do we have any questions on how this mapping function creates our histogram object setup? Nice, nice. All right. So now that we've set up our initial state, now let's see how we can set up our reducer function and what exactly a reducer function is. Well, what a reducer function is that it's a function that gets passed in two things, which is our previous state with a complex state object and an action that we want it to take, which we're going to pass in through a dispatcher. And what the cool thing about the reducer function is that it handles all of our state logic inside of a centralized place. Like what we said, the problem is with the other one, with using state, we have a bunch of different functions set out throughout our entire code base, and it's not all centralized in one place, which will make looking for the functions that change state harder in the future when you want to refactor something. So let's take a look at a reducer function, and let's try going step by step on things you want to do. Oh, let me comment this out real quick so we can start making it. So our reducer function, histogram reducer, and we said that it takes in two arguments. First one is going to be our previous histogram, and we're also going to have a an action. Let's call this an action. And now TypeScript is yelling at us, saying, "Oh, what do we do? How do we use this arrow function?" Like so. It says it has an any type. So let's see. The previous histogram, as we see above, it is of type histogram, which is an array of histogram sections. So we're going to pass that in. Let me enlarge this. And it has an action. And let's call this our histogram action, like that. And what this is that it's kind of like our SetState function before. Like you saw with the SetState function, how you passed in a previous state, like, where is it? Give me a sec. Here, we have a previous user. It's very similar. We can pass in our previous histogram or our previous state value. And what we do is that we can construct a switch statement, which will handle all of our state logic. Like action.type. So what this switch statement does is that we're having all of our functions, like let's say what we want to do. We want to be able to increment one field. We want to randomly pick a field. We want to reset everything, right? And what this switch statement does is that it allows us to do all of these same things, except it's all inside of the same function. So it's all inside one place for us to look. So let's try making a case. This is, and what we see here inside of our action is that it uses something like an enum. And if you guys don't remember from our enum discussion during session 1, what an enum is that it's TypeScript's way of saying like, oh, only these fields are something that can get passed into our function. And this is like a really nice way of saying type histogram action type equals, like this is the same thing as doing increment all or increment 1, but it's a really nice way to do it. And it's really useful for, especially for reducer functions we're making right now. So let's go back. So we want a case histogram action type. And here's the beauty of types. Look at this, like you can just press dot and it gives you everything that you need. So let's take a look at what we want to do when the user passes in an action and they want us to increment everything. Well, first, what do you guys think we're going to want to do to increment the histogram?
You want to like map out the previous histograms, histogram sections?
Exactly. Yeah. We can make a mapper like here and let's call it, but we're not going to return it directly because we're going to want to sort it afterwards as well. So let's try doing that here. Let's like new histogram equals previous histogram dot map. How are we going to map this? Like section, and each section we're going to return another object, which is dot 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 section, and we're going to use y is section dot y plus 1. And what this will do is that it'll increment everything by 1. And this is really where I think our reducer function shines, because if we were using state before, what we'd have to do is that we want to say, oh, we're going to want to do this, and then we're going to want to sort it afterwards. But it'll be like a giant messy function. But here, now let's just sort our histogram. Let's sort it like so with a little sorting new histogram.sort a b e dot y minus a dot y. And what this will do is that this will sort our histogram afterwards and make sure that when we, like, let's say we change 1, it'll make it go a bit higher whenever it changes. And we're going to return a new histogram. Nice. So that's our histogram reducer. And now let's try seeing. Do we have any questions on how this works of, oh, looks like this is not working anymore because we commented it out. But do you have any questions on how this action works? And like how we get the previous histogram, and we use immutable update logic, which means that instead of changing the previous histogram directly, we can only read, it's read only, which means that we can't change it at all. And we do new data to it. And we do new things like creating a new histogram that we return.
Wait, so what would this look like if we weren't using useReducer?
Oh, if we were using useState, so like it would be
Yeah.
something like, actually, let's see, update histogram. Oh, I think it'd be like set histogram. And we're gonna have a function that is going to take the previous. It's gonna do very similar, but the thing is, the problem with doing it this way is that we don't get like a semantic guarantee that it doesn't have any side effects. And the cool thing about reducer functions is that they don't depend on React at all. Like, do you see how we're making our reducer function outside of our React component? That's because it doesn't care about anything else, and it only cares about the things that gets passed into it. And the problem with set histogram is that if you have a lot of state happening at the same time, you might get like some what's it called? Like race conditions where it's non-deterministic. And like if you have a bunch of set states happening at the same time, then you're not guaranteed that one after the other is going to happen. So that's why people really like reducer functions, because it guarantees that, oh, this is going to happen first and then this, which is really nice. Because like I actually ran into a situation before, like on our learning lab, where I was using useState and it wasn't working properly. I had to use useReducer to make it work. So
Wait, you mentioned that it can lead into race conditions. Is that because JavaScript like runs asynchronously?
yeah, it's because like the way that SetState works is that you're not guaranteed to have this line finish and then the next line because of async. So like if you were to like use, let's say for instance, let's say that we separated this, right? We wanted to increment and then we had a separate action to sort it. Like, and then we would call it like what? This isn't the exact syntax, but it'd be something like histogram dot, and then we wanted to call increment all, and then we wanted to call dot sort or something. The problem with this is that it's not guaranteed to sort the incremented version because we don't know if that's going to finish yet because of async JavaScript, which is really stupid sometimes.
Mhm.
And yeah, and useReducer is a way to like stop race conditions and make our code like a lot more consistent with what we want to do. Yeah. So this is a case of when it just like, oh, we're going to increment everything. And we're going to show how this action that we have passed in, like action.type, you can pass in anything else that we want called a payload, and we can change it. Like so, let's say we wanted to have another case. And what we're going to want to do now is, let's see, let me uncomment this out so we can see what we want to do. All right. So what we want to do is that we want to change only one specific part, like object 3 and object 1. Like what we can see is that we have to be a little bit more specific of which one we want to change because it's not going to be all of them. And we can do that through something called a payload. And a payload is something else that we pass in inside of our histogram action. Like we see here that we're passing in a type. We can also pass in more things if we want to be more specific. Like let's say we wanted to change only a specific section. And we can do that by passing in the section name and reading that inside of our function. So let's see how we would do that. We'd have another case, which would be Instagram. Oh my goodness. Increment 1. And let's see what we want. So what we need is that we want to, it'll be very similar to the previous one where like we make a mapping function, but this time we have to make sure that we only change one of them. We only change the one that we want to change. And we can do that like so. Const new histogram roles, new histogram.map section. And let's see. So we can't just simply return it because we have to have like an if statement to see what we want to do. So we have like if, and the way we would use this function is that we're going to pass in as well the section name that we want to change inside of our action. So we're going to go through each section of the histogram and be like, oh, if the section's name or X component is equal to the action's section name that we want, then we're going to return, what are we going to return? The new section with the Y component changed. Oh, it is yelling at me. Why is it yelling? There we go. Operator plus cannot be applied to Y any. Interesting. Let's see why this is the case. Debugging. If section.x. Okay. Did I change anything? I'm confused.
Oh,
Was
I'm
it
not sure.
different
I
before?
just noticed it's like the same as we had up there, like line 44, but I didn't actually notice any changes.
I don't know. It yelled at me before, but looks like it's good now. And
Yeah.
then, so that's our case if it is the one that we want to change. But if it's not the one we want to change, else, then we're just going to return section like so. Oh, why is it yellow? There we go.
I think you,
Else we're going to,
oh, no.
sorry. Okay, nice. So, and then, so that's our mapping function. And then we're going to want to sort it again. So let's just sort. This is a bit of a code smell. There's probably something we could do. Like if we want, we can probably just sort at the end of new histogram instead of having to rewrite new sort each time, but that's okay. We will live with this. We will make it better in the future. And yeah, so with this in case, now we can see that, oh, something's yelling at us. Is it? That's nice. Okay. So now we're gonna have, let's see what else we want to do. We have our increment one case. What other case do we want to do? We're gonna want to reset everything. So you want to try, let's see. We don't need to walk through how we're going to reset. We can do that as an exercise later afterwards. So let's just, in the interest of time, let's have our reset still there. There we go. And we're going to do the reset case later for practice. But yeah, so let's see. That was all, that thing that we just went over was how to set up the reducer function. And we can see that everything that we want to do inside of our state is inside this nifty little function here, and it's not spread out throughout our entire code base, which is really nice. And now let's see how we would use this inside of our function. And the way we do this is really similar to using useState in React. What we have here is that we have a getter function, a getter variable that we're going to use to grab our data. And we're going to have our, like, instead of setState, this is going to be our dispatch function, which we're going to call to change whatever we want to change. And the things that we pass into useReducer, what we pass in is that we pass in the function that's going to be our reducer. That's going to change the state that we just made earlier. And we're also going to pass in the initial state for our function, or the initial state for our reduced histogram, like so. And let's see now how we would use our histogram, how we would use it. So we see that we can call our dispatch function like so here. Let me grab another one here, add to y. And what we do is that when we pass our dispatch function, we're going to pass in the action that we want to take. Like as we see here, we saw that our dispatch function, if you look back up above in our histogram reducer, it takes in a previous histogram and an action. And what this does is that it'll pass in the previous state already for us, and we have to specify what action we want it to take. Like here, we're going to have an action that's increment one, and then section name. And that's how we can call our function. Does this make sense of how we can use our reducer with a dispatch and passing in our action inside of our function?
Oh, wait, can you explain again how the dispatch function is linked to the thing we wrote above?
Yeah. So the way that it works, like React does this for us, but what it does is that it's smart enough to say, oh, the previous histogram, because by the time we write the function, like we don't know what state it's in right now. So it'll pass in by default the current state that when we reach this function, and we have to specify the action object that we pass in. So if we look at our histogram reducer, we know that it takes in both a previous histogram and it takes in the action object. And what we're writing here is the action object that we want to pass into our function.
Okay.
Good?
Yeah, I think so.
Nice. All right. And we can do the same thing here. And we can see that we can use our reducer function inside of our React app. And we can do this really nice. And it's all nice and neat in the same spot. And it works properly. So let's go back here. scroll. Yeah. And so the reason why we might want to use reducer is that, like we said in the past, with primitive values, it might be in like useState is really nice for primitive values because we can just use our setState variable and our callback. But the thing is, later on, when we are making really, really large web applications, like sometimes it's hard to see where everything is. And we want centralized state management through useReducer and useContext. And there's a couple of rules of thumb to see if you should switch useState to a useReducer. And in general, the times you might want to use reducer is for centralized logic to manage state with, like, let's say we had incrementing, sorting, resetting, or if changes in the state depend on each other, like what we saw before, where we wanted to increment something and then sort it at the same time. And we want to do that in the same function as opposed to doing it two separate set state calls because we don't want to have race conditions. And it's also useful for when we have data that is hard to represent as primitive types, like anything that is a referential data type or anything that is not a primitive. And in conclusion, this is really nice, and useReducer is another tool in our toolkit that we can use to help write cleaner code and make everything more succinct and more precise for people in the future reading over it. You have any questions?
So like, even if you're mainly just working with primitive types, you think that like it still could be nice to use useReducer just
Yeah,
because everything's in one place.
yeah. Like sometimes, like we say here that these are all separate types that you might want to use reducer. And in fact, if we look at the use reducer, like on React documentation, like we see that their example of use reducer still is a primitive type. Like if we look here, they have a count that's just incrementing count +1, count -1. And sometimes, like, I don't know, personally, I would like it as well, because like the good thing about reducer is that, like, as we said, everything's all in the same place and there's no side effects, and like it's more safer sometimes because it doesn't depend on React at all.
I see.
Right. All right. So I guess if we have some extra time, let's try do you want to try writing our reset case of how we would handle resetting?
Oh, sure.
Yeah. Let's see. So we have here, and what else do we think we need to add in?
I remember we talked about the reset function.
So then, like, you said here, this is really nice. We can do with TypeScript and enums. Like, you don't have to remember what we called it. We can just do a dot, and it tells us everything for us, which is really nice. And let's see, how do we want to reset everything? So we know that each histogram section has a name, and it has a number and a weight. So how do you think we can change just the number section?
Wait, I forgot, but when we're resetting this, is it supposed to go all the way back to 0 or back to like the 2015 and 10?
It returns back to 0 for everything.
Oh, okay. Then you could do something like I forgot what we called the old thing, but like, yeah, you use like new histogram equals like old, yeah, previous histogram.map. And then yeah, you use like R and then ARR or whatever, and then yeah, error function, and then ARR dot y equals 0.
I think like what we need to do in this case is because like each R is an object, and we want to make sure that we keep the rest of the
Oh,
object the
right.
same.
Yeah, so it'd be yeah, curly braces and then spread operator. Yeah, and then yeah, y equals 0.
Nice. And then something else we have to do as well, if we want it to be nice, like we're probably gonna have to sort it as well. So we have to sort it alphabetically, which is a bit weird. But let's see, new histogram dot, and then the way we would sort it would be like A and B, return a dot x. Is it greater than b dot x? No, I forgot. Do you know how I forgot how sorting works with strings, but we'll see if this works. One. I think this is it. This will sort it alphabetically and give us like, let's see if this works. Oh, and we see that React is still yelling at us even after we wrote in the case reset. And now let's see why that's the case. It says here, no overload matches this call. And the way that we can debug things is by looking at TypeScript, and you can see how they help us debug our applications. Like if we see at the return type of our histogram reducer, we can see that it's either histogram section or undefined. And why is that the case? That's because inside of a switch statement, even if you pass in an enum, like to guarantee you only get these 3 sections, you still have to write a default case or else it'll yell at you. So like if we write in a default and we're gonna have like, oh, return the previous histogram, we see that our reducer function, it says that it only returns a histogram instead of possibly returning undefined like last time.
I think you
And
also have to return the reset function. Because I don't
there
think
we go.
Yeah.
Thank you. Yeah, nice. Follow through case and switch. Thank you, thank you. Return new histogram. And we see that it works as intended. So yeah, looks like we have, nice. So we covered useReducer today and how to use it, some things in TypeScript, like using enums, interfaces, and yeah, I think that was great.